I just wanted to kind of walk you through this Model My Watershed interactive. This is a really cool tool that we'll be using so that you can kind of look at what is happening. And so we'll discuss exactly how to go through this interactive. And the first thing that you want to notice is you can do all these things. You can select certain areas, you can analyze them, you can even model in the watershed. So let's go ahead and get started and we'll kind of look at it. You might notice this is our general area. We can jump to a location, so we'll get started. I really like the select a boundary tool. It gives us different things to choose from. I'm going to pick school district because we're in school. It's for our class. And so when we look at our school district, you can see the boundaries, you can see the town names. That's great. You can also notice over here we have different pieces to analyze. And so the first piece here to analyze is streams. You can see in our school district we have first order stream and a second order stream. You can see the length of the stream, the slope. We do not have any larger streams and rivers in our school district. And so it gives you the total length of them. And I like agricultural areas. So kind of consider in the watershed, why would you want to know where rivers and streams go through agricultural areas? Kind of consider the runoff and the things that the infiltration that might happen around the river, the watershed in agricultural areas that might not be in non-agricultural areas. Also, the non-agricultural areas, we can see we have more of that, which is kind of surprising considering our school district. What other kinds of things? What is going to be runoff in those areas? You can look at land. What kinds of land do we have? We clearly have the most deciduous forests and cultivated crops. So we have both agriculture and sort of wildlands. You can kind of go a little deeper into that and see those percentages in exact numbers instead of just on the graph. The soil types that we have. So we kind of discussed soil in a unit earlier, kind of looking at the type of infiltration that we have. What does it mean to have slow infiltration? Like we have the most slow infiltration. How is that going to change and be affected by rainfall? We can move over to terrain. We can sort of see the elevation. We have some elevation. We're a little flat, but some elevation that we can consider. What does elevation do in the watershed? That elevation, gravity drives the water speed, and the water drives the watershed to its pooling locations. And we can see climate. Okay. Point sources. Okay. So we have Morgantown and Trafalgar. Okay. We can notice on the map, we can see those blue dots when we hover on them. And so we can see exactly where those point sources are. Animals is interesting. These are agricultural animals. So we can see how many chickens, how many cows, how many horses, how many hogs and swine that are reported to this system. And then water quality. We don't have any records for our area, but there are records in some other areas. So if we look up here where it says analyze, monitor, and model, I'm going to monitor. We could pull a lot of data from that, but we're not going to really use that in our class. If we look at model, that's where it's going to get a little interesting. We could go ahead to the site storm model. So you can read, I know, but it says it simulates a hypothetical 24-hour storm. Okay, so we can really look at, we'll click on it. Okay, that'll take a second. So if we look 24-hour hypothetical storm event, we have evapotranspiration, so from the plants, runoff. Now runoff is going to carry a lot of the things off of the top of the surface into the groundwater, into the surface water. That's something to kind of consider and think about. How does a storm affect the runoff that occurs? And infiltration, so actually going into the ground. We have a lot of infiltration if we only get 2.5 centimeters of rain. So if we look over here at this precipitation, then we can see how bad of a storm really was it. These water volume numbers are just phenomenal, kind of thinking about the total water volume from a 24-hour storm, but 2.5 centimeters, that's only 1 inch. That's 1 inch of rain. So if we go up to maybe, let's see, 2.5, 3 would be 2 inches of rain. there's about 3 inches of rain. We kind of have the same. Well, we have a lot more after it refreshed. That runoff is going to be pushing our infiltration down. So consider in a strong storm event, maybe even we're going to, well, let's go extreme storm event. Let's go as high as it goes, 25 centimeters of rain in a 24-hour time period. That's a ridiculous amount of rain that doesn't happen very often, but we can see that runoff just dramatically increases. And so that's what we really want to kind of look at and consider in a serious rain event. What is washing into those streams and lakes? What is it that is running? What is going with that water? And so that's kind of what I wanted you to consider and look at while you were using this tool. So what I'd like for you to do now is to consider a different area. Like, we know our area. We live here. We see when it floods. We see when our front yard is soggy. We understand that. So to compare and look at the way that runoff and infiltration changes, that's pretty important. But what I'd like for you to do is go back. You're going to click Model My Watershed, and you can get started. You can go to any location you want to. Like you can see, I looked at Reno, Nevada. You might look at some place that you know has a lot of lakes. You might go to perhaps the Chicago area, a big city, and see what happens. And I want you to consider those same kinds of, so we'll kind of pick Reno again. I'm just not wanting to search for it now. If we zoom out a little bit, I'll just go a little bit further away. Let's pick someplace in Missouri. Zooming back in. Okay. It's not wanting to play very nice right now. All right, there's our school district lanes for Missouri, this area in Missouri. So what I do like about this model as well is that you can see the rivers and you can see the topography of the area. So you can really see those higher elevations and almost understand that watershed just by looking at those topographical maps. But we'll pick Honey Creek here. And so we can see the outline of that school district, and it gives us the same kind of information. So let's look at their land. And their land has got a lot more pasture than we had cultivated crops, but they're still very similar to us in deciduous forest. And then will it be similar when you go ahead and look through when you do the model? Do a site storm model there. Looks very similar. Let's go extreme storm and see what happens. We have a very similar reset there. Let's go back to the model. You can see water quality, what that is happening. We don't have a lot looking at that. All right. I'm going to go back and see if we can show. We're going to select that one. We'll keep with the same idea. And let's go to model and go watershed multi-year model. Okay. So we're looking a little bit, and I'd like for you to go back to our school district. And when you are on this model, maybe, then you can kind of see how much water is run off, where the stream flow changes, right? And so I want you to investigate. I want you to investigate the changes that you can add to this area. So weather data, land cover, conservation products. If we go to land cover, what if we changed that? what if we went to, we could see all the different years that there was land cover. So if we go back to 2001, hay pasture, let's just kind of pick one. We'll look at 13108. If we go to the current, we have less hay and pasture. Okay. So, all right, we're going to go. We can look at conservation practices, and this is where it can get a little interesting. If we look at conservation practices, let's say we reduce tillage, we can see that there are 1,330 hectares of row crop. What if we change that? So before we go changing things, let's look. Our surface runoff is 10.8 centimeters, okay, with no changes. If we modify that to 1,000 hectares of reduced tillage, so we convince farmers to use a more regenerative practice, we maybe subsidize them, whatever it would take. Let's look and see how that changes our surface runoff. Okay, after the change, our surface runoff is 10.17. So that is a different number. Okay, it doesn't change incredibly much, but we can see maybe a little bit of difference. And let's kind of go back and we'll take that off to make sure we're looking at exactly, make sure we look down through the months. When do we see that? What changes do we see? And so by reducing tillage, we went down a piece, 0.01 centimeters. What is another conservation practice that we might, maybe we go complete no-till. Let's see what we got for that same 1,000 acres. Okay, so we had 10.18. If we go no-till agriculture in 1,000 acres, what are we going to get? 10.12. So we have less surface runoff. All right. Let's add conservation tillage to 300. So the rest of it. What do we change? Okay, so we're going lower. What other conservation practices might we want to do? Stream bank stabilization. Sounds great. Okay, so the length of the stream in agriculture areas and in the watershed is 751. Let's go with something reasonable. Enter length between that is greater than 0 and less than 199. So they're saying that's not reasonable. So we'll go 150. Okay. Still making reductions, small reductions. And would that be different in our area? So go ahead and make those changes to our area and see if it's the same minimal change or if it is a bigger change. Okay. All right. So play with this simulation. I think it's really interesting to kind of consider the watershed, to be able to see real data and see how that might change when you can try conservation practices. So you have two things to do. One thing, consider an area that is not ours and kind of look at how it compares. Maybe something that you know is very different, like a desert area or a very hot, very urban area. And two, go back to our area and look at the conservation practices. See what conservation practices would be best to reduce surface runoff in our area.